Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about There Goes. And if I have time, ants have lasers in space, and I did not make up that sentence off the top of my head and just combine random words. It's a real thing, and of course, taking listener questions about all things in the universe, because that's what this show is about. We record every Thursday at 4 p.m. Eastern, so call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about starting from the beginning. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at Cosine. For the next half hour, your agent of the stars. We've got an exciting show for you today on Space Radio, where we talk about all things in the universe. That's right, in only 25 minutes. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus. So call 888-581-0708. Get those calls in. You can also follow along on the live streams on Facebook, on YouTube and Twitch. Go to spaceradioshow.com for the links. Hello to the Space Cadets tuning in live from Berlin, from Amsterdam, from Lancaster, California, from Nova Scotia, from Shorewood, Illinois, and all other places around the world. We'll take questions that you send there too. Seriously, folks, I've prepped 10 minutes of show material absolutely top, so get those calls in. Before I start taking those questions, though, I wanted to share some interesting bits of news I caught recently. And this is a little bit of an old story, but it's a wonderful opportunity to talk about some amazing science and technology and engineering that are happening right above us. And I'm talking about the GOES satellites. And this is a network of satellites managed by NOAA, the National I honestly don't know what NOAA stands for. Wow. Major fail, but I'll figure it out and I'll put it on the show notes, or someone in the chat will correct me and I'll get to it. And it's also NASA helps out with these satellites too, helps launch and manage them. These are astronomical observatories. These are atmospheric astronomical. These are satellites that are looking inwards. These are satellites that are monitoring the Earth's weather systems continuously all the time around the globe. They're a network of satellites, each one dedicated to a certain region of the globe. These things are constantly observing and taking measurements of our own atmosphere, of movements in weather systems. And these provide the absolute most important data that feeds into massive simulations that go on to predict weather systems. So everything from hurricane storm tracks to your weekend weather outlook is ultimately sourced in large part, from the GOES weather systems. And thank you, Nilgiri, on the chat. NOAA stands for National Oceanic and Atmospheric Administration. I totally blanked on that, but thank you for the rescue in the chat. Now, there's a problem, though. The system is kind of old and aged and decaying and not as good as we would like it to be. And so NASA and NOAA have instituted a program to begin replacing them, and this program is going on for a few years. And the latest one has a hitch. The latest one, GOES number 17, has a problem. The problem has to do with his infrared instruments. In order to observe weather at night, which is as important as observing weather during the day, obviously the night side of the Earth is kind of dark, hard to take a picture, so you need infrared so you can see the flows and motion of heat, of warm air moving around in our atmosphere. That device requires cooling. The coolant system failed. NASA engineers, NOAA scientists are trying to figure out workarounds. There are backup plans in place, but it does mean there will be a gap in our knowledge. It's not like we'll have like no information at all about, say, the western half of the United States, but we won't have as precise forecasting abilities as we would prefer without this infrared instrument on board GOES 17. And just the massive industry that the GOES system feeds into, this massive pipeline where data are coming down continuously, nonstop, feeding into these massive, super sophisticated, some of the most complex simulations of the Earth's weather and climate you can possibly imagine, feeding and trying to predict in this messy, chaotic, convoluted, high-dimensional, non-linear, super interesting problem that we call the weather, in order so that we can have proper forecasts going out days and even weeks. GOES is absolutely critical for that. And that's the latest greatest when it comes to space, but it's time to have a conversation. People are saying the chat is stuck for some reason. Before I keep going, give me a sign that you can see me, that you can hear me in the chat. Or is it just YouTube, or is it just Twitch? Low-level glitch. Okay. People are saying they still see me, they still hear me. Is it... Oh, I see. The chat that's embedded in the stream has flaked out. Oh, I see how it is now. Yeah, that's weird. I don't know why the chat that's embedded in the video is done. I'll have to investigate that later, but we can proceed with the show onwards. Okay, thank you for the clarification, Paranor 001. It's on screen. Okay, good. I do want to get to your question, Nilguri. There's a wonderful question on the live stream from the Space Cadets on YouTube, specifically Nilguri on YouTube, asking about a particular object in the sky known as Einstein's Cross that kind of looks like a cross and doesn't look like, circles or balls or spheres, or discs. When you think about astronomy, there's only a certain limited number of shapes that you tend to see in space. There's wispy nebula, there's tight compact balls that we call stars or planets, there's rings and disks. There aren't a lot of triangles, there aren't a lot of boxes, and there aren't a lot of crosses, but there is one particular intriguing shape that you can observe known as Einstein's Cross. Unofficially, the official designation, of course, is Q2237 plus 030, or if you're feeling informal, if you get to know, it's QSO 2237 plus 030. 5 is its official designation phone number. And what it is, when you look at, if you just look at a picture, if you happen to Google search Einstein Cross, you'll see a blob in the middle surrounded by 4, they almost look like flashlights. Flashlights in the distance, 4 objects around that. And if you didn't know anything about general relativity, you would think that's pretty dang weird. How in the world is the universe capable of making cross-shaped objects like that? The answer is, of course, general relativity. One of the biggest lessons we got from Einstein's theory of relativity is that light follows the curvature of space, that the bending of space-time itself influences the motion of everything, and light is a thing, last time I checked, and ergo it must also be influenced by the bending of space and time. So you can bend light. Gravity itself, massive objects can curve light like a lens. We call these things gravitational lenses. This happens around even our sun. This is one of the first experimental verifications of general relativity. It's not a very big effect. It's a very, very minute effect that requires very delicate and detailed observations. So it's not like you're going to see it during the next, say, eclipse with your eyeballs. But we can go out in the universe and we can find things much, much larger than our sun, like galaxies, like clusters of galaxies, and so on. Really big, massive objects that can bend light like a lens. And usually, if you think about what does light do through a lens? Like, go around your room or your office and start looking for lenses, pieces of glass. It could be bottles. It could be eyeglasses. It could be window panes that are warped. It doesn't matter. Look at the ways that light is bent and curved and distorted by a piece of glass. Whatever you can concoct with an arrangement of lenses with glass, you can do with gravity. You can do with massive objects. You can create gravitational lenses in our universe. And the Einsteins Cross is one peculiar arrangement of gravitating objects that are bending the path of light itself to give us an image. So what we're looking at when we see the Einstein's Cross, we see a heavy object, and behind it is another object. And the light from that object is following multiple paths. It's getting distorted like a funhouse mirror or funhouse lens around that intervening object. So when we look at it from our perspective, it looks all weird and cross-like, hence the name Einstein Cross. Usually gravitational lenses don't look like crosses. Usually they look like arcs. Usually they look like a squiggly banana, like rotten banana kind of things that make the background galaxy heavily distorted. But in this case, it looks like a cross. And it looks like a cross because the intervening object is heavily elongated. It's really, really long. It itself is very sausage-shaped. And it's not 100% lined up perfectly with the background object. So you get a very interesting path of the light around this intervening object that ends up giving you 4 very distinct images around the central object, and hence the cross-like appearance. I maybe would not have gone for the cross. Perhaps I would have gone for a plus sign. It looks like Einstein's plus. But you know what? I'm not in charge of naming things, as I usually complain about. Excellent question, Neil Gurry, on the Space Cadet YouTube chat on the live stream. You can join that live stream. Go to spaceradioshow.com for the links. You can also call 888-581-0708 to talk to me directly, not face-to-face, but second best. I'm Paul Sutter. This is Space Radio. This show is brought to you by you. Visit patreon.com/pmsutter to learn how you can support this show and the station WCBE that supports the show and brings it to you over the magic of radio. Actually, it's not magic. It's science and technology and engineering. I'll see you after the break. You're welcome, Neil Geary. All right. I think I'm going to do... Is the in-stream... Man, the in-stream chat is still stuck. Sorry about that, guys. I'll have to diagnose that after the show, as usual. Science. Let me see. I'm going to answer... I've got a question up here about... Who asked about special relativity and going close to the speed of light? I gotta find a better way to organize my questions. Oh yeah, Mark Hawk. Relativity question. And then Twitch streamers, if you've got a question, let me know by asking the question. Otherwise, I'll do the news story. But I'll get started with Mark Hawk. All right, here we go. Welcome back, everyone. I'm Paul Sutter, and of course, this is Space Radio. We've got another Space Cadet live stream question ready to go. But remember, you can join the conversation by calling 888-581-0708. You can also follow the live streams. Go to spaceradioshow.com for the links. We got another wonderful question from the Space Cadets on YouTube. This time, Mark Hawk asking about relativity and getting closer to the speed of light. He's asking like a hypothetical question. Let's imagine, this is a great thought experiment. Let's imagine you were in a giant spacecraft with the biggest, best rocket you could possibly imagine, and you are just shy of the speed of light. You're at 99.999, let's go ahead and do it, 99% of the speed of light. Like, you were just under the speed of light. And you're blasting all of your rockets except one. You've got one more ready to go to push you over the line. And you flip that switch, you hit that button, you do the thing to activate that last rocket, and here we go. What is your speed? Your speed is not the speed of light. Your speed is not greater than the speed of light. Your speed is still only 99.9999. I forgot how many nines I started with, but just add one more 9. You will inch closer to the speed of light, but you will not reach it. And even if you had a surprise extra rocket, now I've got you, physics. Boom, another rocket ignites, still 99.99999% of the speed of light, not 100. Not there yet. Close, but no relativistic cigar. You are not going to make it. You are never going to catch up to the speed of light, let alone cross it. And that's because of relativity. This is one of the most fundamental insights that Einstein was able to make way back in 1905. It comes from a fundamental relationship between space and time that we call, this fundamental relationship has evolved into a theory that we call special relativity. And the reason you can't do it, one way to explain it, we all know E equals mc squared, right? This is like kindergarten level stuff. Everybody knows this, E equals mc squared. I want you to take out the c squared. The c is just a number. It's a conversion factor. It's the speed of light. It doesn't matter. It just, what the bare bones of the equation, the most important part of the equation that you need to pay attention to is E equals m. Energy equals mass. Energy is mass. Mass is energy. If you have mass, congratulations, you have energy. If you have energy, congratulations, you have mass. These are two sides of the exact same coin, which means a hot cup of coffee weighs more than a cold cup of coffee because the hot cup of coffee has more energy than a cold cup of coffee. It means if I were to throw that cup of coffee, it would have more mass than a perfectly still cup of coffee. Because energy is mass, and all kinds of energy, thermal energy, kinetic energy, chemical energy, whatever kind of energy you have, all that equates to some sort of mass. So as you go faster, you have more kinetic energy because you are a fast-moving object, which means you have more mass. The faster you go, the more mass you have, which means if I'm going 99.999% of the speed of light, I have an incredible amount of mass. Way more mass than I started with. And I flick on that rocket is barely going to make a dent in my speed because now it has to push a lot heavier thing than when it first started. So that first rocket that I ignited had the easy job. It just had to push my spacecraft. The 100th rocket has to push my spacecraft and the mass due to my incredible kinetic energy. And so you don't get the same bang for your buck. You don't get to move. Every rocket doesn't give you 10% of the speed of light. You get diminishing returns. And now that rocket kicks in, you do go a little bit, tiny bit faster, but you'll have even more mass. So you kick on another rocket, you get less oomph out of it. You kick on another rocket, less and less and less. And nature just happens to conspire based on the fundamental relationships between space and time that in order to cross that barrier, in order to make it to the speed of light, you will end up having infinite mass which means you need an infinite number of rockets, which isn't likely to happen ever in our universe. So you will never cross that barrier of the speed of light. Excellent, excellent question on the YouTube live chat right now. And I'm going to slide right in to another question on the chat, this time over on Twitch. That's right, we simulcast both on YouTube and Twitch. We've got a question from Kylus84. How likely were dark matter stars to be real? Now, we know of stars, right? Stars are just things. They're balls of hydrogen and helium and a few other things that have compressed down to such as a dense point that they can ignite nuclear fusion and they can glow. And in some cases, they can even host habitable worlds with oceans on their surface and little critters going around talking about the stars. Now, there's another component to our universe, a major component to our universe called dark matter. Dark matter is a form of matter that does not interact with light. We can't see it. We can't touch it. We can't even taste it. But we can see its gravitational effects. We can see its influence on the motion of stars within galaxies, on the motion of galaxies within clusters of galaxies, and on the evolution of the universe itself. So we can detect it, just not with our eyeballs or our telescopes directly. Now, the question here is, can dark matter ever, whatever this substance is, which fully admit we do not fully understand, we do not know what the dark matter is made of, we know it exists, we don't know what it's made of, can it ever clump? Are there dark matter stars? Are there dark matter planets? Are there dark matter solar systems with dark matter people hosting the dark matter edition of Space Radio? Maybe, but it seems unlikely. It seems unlikely based on a plethora of observational evidence that dark matter can clump up that tightly. It is a big debate in the cosmological community, those who study the workings of the universe, whether dark matter is smooth peanut butter or chunky peanut butter. Is it perfectly smoothly distributed throughout a galaxy, or does it clump up? If it clumps up, we're pretty sure that the smallest clump of dark matter is going to be about the size of a solar system and not any smaller. We don't suspect there are going to be very small, compact objects, things like stars, things like planets that are made entirely of dark matter. We think what makes dark matter work prevents it from clumping up that tightly. It has to be at least a little bit smooth, and most likely a bit smooth. So, but chunky or smooth is a relative thing. It's not that chunky. It's not like actual peanuts. It's at least some form of chunky peanut butter, dark matter in our universe. And maybe someday we'll actually know what it's made of. Unlikely to be peanuts. Most likely something else. Excellent question on Twitch. Thank you so much, Kylus84. We're almost out of time today on Space Radio, though. I know. So sad. But before we go, it's time for the blue shift. I'm Paul Sutter, and you're listening to Space Radio, and this is the blue shift, my opportunity to get just a little bit closer to you. And I want to talk about another project I do, another thing that I do in this wonderful world of science communication. And it's a blog. And I know I'm like 2 decades too late on the whole blog thing. But you may have noticed in this show that every once in a while, especially in the blue shift, I inject some interpretation where I don't just present the science, but I talk about, say, how the science is presented, or how the science is done, or how the science ought to be done. And this is a very important part of my life, is thinking about the relationship between scientists and non-scientists, the obligations that scientists have to their communities, how science communication ought to be approached. So it's not necessarily philosophy of science, but philosophy of science communication. What are the essential concepts? What are we hoping to achieve? What are our goals? I gather these kinds of thoughts and meditate upon them for your reading pleasure in a blog. You can go to pmsutter.com/notes. The name of the blog is Ab Initio. Ab Initio is a Latin phrase meaning from the beginning. It's used in science and law and philosophy, where the point is to start an argument from first principles. What's the bare bones? What's the basic, most essential concepts? And let's talk about those and build from there. It's very short pieces. It's usually no more than 500 words or so, just a few paragraphs, quick bites every week. They come out every Sunday evening. It's about questioning assumptions. It's about building discussions, about sparking debates. A lot of times in the blog, I raise questions where I don't know the answer, or I make a point that I don't necessarily agree with, but I don't know what the right answer is. And I talk about science. I talk about science communication. I talk about mistakes made, what I believe to be mistakes made in science communication by other science communicators, by journalists. I talk about what I think. I outline my approach to science communication, what I believe in, what I'm searching for, what I'm trying to find out, the relationships I'm trying to build. To give you a sample, the latest titles in the blog, in these blogs, one is Go Ahead, Say the Dangerous Thing. Another one is Don't Go Chasing Audiences. Another is Don't Trust the Data. Another is Clickbait Science, so on and so forth. That gives you a flavor. That's pmsutter.com/notes. I think you might enjoy it. I think you might enjoy reading that, the perspectives of science communication from a person who is a scientist and who is actively trying to become a science communicator, but was not trained in this and is learning as they do it. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. It's also brought to you by you. That's right. Go to patreon.com/pmsutter to learn how you can contribute. You are incredibly important. Also important, Greg Moebius is back and better than ever. Thank you to him for producing, Dan Michalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Why don't you join me? 888-581-0708. We'll have a fun little chat. You can also follow the live streams on YouTube and Twitch. Go to spaceradioshow.com for the links and all the info, the podcast version of the show, all that good stuff. Thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End of transmission. Space Cadets, that was a great show. Great questions. Great conversation. Sorry about the embedded chat in the video dying. I'll fix it this week. I'll see what's going on. It's always something. Right, Greg?
No, we had a show 3 shows back where absolutely nothing
3 shows back. Remember that show?
Yeah, nothing went wrong.
Like 3-4 weeks ago where it was like smooth sailing, no problems. Those were the good old days.
They were.
And then you came back.
I know.
And then you came back.
I'll never leave again.
By the way, I believe the Space Cadets love you, Greg. You want to come in and say hi to the Space Cadets?
Love you back.
He loves you back.
Love you back.
All y'all. At least the microphone work. Yes.
Thank you.
That's Greg's. That's Greg.
It's my deal.
It's all Greg.
I have absolutely nothing to do with the video. That's Paul.
And guys, Space Cadets, good guy. Thumbs up, good guy. They love the work you do.
That's great.
You've got fans, Greg.
Hey, I'll take them.
You have more fans on my show than your show. How you feel about that?
I love it.
You love it. You'll take it. You'll take it.
Take it.
I have more fans on other shows than my shows. Space Cadets, what should I call the show? I need a name. Please give me a good title for the show. What nationality are you, Greg?
I am German, and I have some French and Dutch in me as well. And I notice we have a viewer from Berlin today.
Yes.
So, hey, Berliner.
Greg has a better radio voice than me. Check this out.
Oh, I don't know about
Give
that.
him your radio
I don't
voice.
know about
Just say something cool radio.
This is 90.5 FM and HD, WCBE Columbus. Hey, I get paid for doing that.
You do. You should. That is like butter for my ears. Like right in there. It's so smooth.
Okay.
Oh, it's like chocolate.
The chicks dig it.
The chicks, and by chicks he means infant chickens that have just hatched. They hear the voice and they start chirping. They think they're going to get some worms. It's a very, very odd thing, but we'll take it. Free Tommy Robinson in space. Give me more space.
Give me more
I'm
space,
not going to
Alan.
call the episode Space Radio Live. It's already Space Coast Coast to Coast. Something topical. Give me something good, guys. What should I call this episode? Age of Apocalypse? You guys are killing me. Tommy Robbins. UK politics, yeah. Okay. Yeah, no cursing, folks. We've got strong filters. This ain't Sky's Twitch stream. We keep it family friendly. Public radio.
Please. Good ones? Any good ones?
Space to the Nines.
Space to the Nines.
How's that connect, Nancy? Space to the Nines. How does that connect to the topic, or any of the topics? Oh, nines, like the speed of light, getting close to the speed of light.
Oh, there you go.
Sorry, I don't even remember what happened like 20 minutes ago.
Paul's a little slow today, folks.
I am very slow every day. I have very, very short-term memory buffers. It's in and it's out. I like that. Space to the Nines.
That's it.
Yeah.
Makes sense.
Yep. Space to the Nines. Thank you, everyone. Space Cadets, I will see you next. We're back next week, right?
Back next week.
Back next week.
Mm-hmm.